Good morning to everyone. I'm Manchula. I'm working as a assistant professor in Rajiv Gandhi College of Engineering and Technology, Department of IT. Today, I'm going to talk about adders and subtractors in combinational circuits. First, we see what is combinational circuits. A combinational circuit is made up from basic logic and or not and NAND gates. It is used to connect and combine together to form a complicated circuits. There are three ways for specifying the combinational circuits, that is Boolean algebra, truth table and logic diagram. In generally, the combinational circuits are classified into three types, that is arithmetic and logical operations, data transmissions, and code converters. The arithmetic and logical operations are used to performing the basic arithmetic and logical operations in digital systems. The example for the arithmetic and logical operations are adders, subtractors, and magnitude comparators. Next, we move on to the data transmission. Data transmission means you are transferring a data from one place to another place. The example for the data transmissions are multiplexer, demultiplexer, encoder and decoder. Next, the final one is the code converters. Code converters means we are converting a one form of code to the another form of code. The example for the code converters are binary to gray code, gray to binary and BC2 to XS3. In next, we move on to the adders and subtractors concept in detail. First, we see the adders concept. In adders it has two concepts are there, that is half adder and full adder. Half adder means you are adding two inputs. It can produces the two outputs, that is sum and carry. The two inputs are designated as AGN and ADDN bits. The two outputs are sum and carry. These two inputs produces the four possible combinations of inputs from 0 to 3, that is 0, 0, 1, 1, 0 and 1, 1. This is the truth table for the half adder. In that, the x and y are designated as the input for the half adder and s and c are designated as the output for the half adder. In that, it has four possible combinations of inputs. If the both inputs will be low, that is x and y will be low, the sum and carry will be low, that is 0, 0. The next, if any one of the inputs will be high, it produces the some value will be high and carry will be as 0. If two inputs are will be high, the some value will be 0 and high value, the carry value will be high. Next, from this truth table, you can derive the expression for the half adder. This is the expression for the sum, that is x exclusive with y. Then equation for the carry is xy. From these expressions, you can derive the logic diagram for the half adder. This is the circuit diagram for the half adder. Next, we move on to the full adder concept. Full adder means you can adding a 3 bits and it produces the two outputs. The three inputs are add and bit and previous carry bit. The two outputs are sum and carry. These three inputs produces 8 possible combinations of inputs from 0 to 7. That is from 0, 0, 0 to 1, 1, 1. That is, this is the truth table for the full adder. The x, y and z are designated as the input for the full adder. The x is the add bit and y is the add bit and z is designated as the previous carry bit, and s and c is for output representations. S is for sum and c is for carry. This is the truth table. If all the inputs will be low, both sum and carry will be low. If any one of the inputs will be high, the sum value will be high, the carry is 0. If any two inputs will be high, the sum will be 0 and carry will be high. If three inputs will be high, both sum and carry will be high. From this truth table, you can derive the expression for the sum and carry. This is the expression for sum and this is the expression for carry. From these expressions, you can draw a circuit diagram for the full adders. Next, we move on to the subtractors concept. Subtractors means we are subtracting 2 bits. In subtractors, there are two concepts are there, that is half subtractors and full subtractors. Half subtractors means we are subtracting 2 bits. The two bits are minuend and subtrahend. It can produces the two outputs, that is borrow and difference. You can in two inputs it can produce a four possible combinations of inputs from 0 to 3, that is 0 0 0 1 1 0 and 1 1. This is the truth table for the half subtractors. The x and y are designated as the input for the half subtractors, and d is and b is for representing the output for the half subtractors. D represents the difference and b represents the borrow. It has the based upon the truth table, it can produces the expressions for difference and borrow. From these expressions you can draw a circuit diagram for the half subtractors. It is the complement of the adders. Next one is the full subtractors. Full subtractors means it has three inputs and two outputs. The three inputs are subtrahend, minuend and previous borrow bit. It is designated as Z. The two outputs are borrow and difference. This is the truth table for the full subtractors, that is x, y and z. X as minuend, y for subtrahend and z is the previous carry bit, and d represents the difference and b is for borrow. Next, from this truth table you can derive the expression for difference and borrow for full subtractors. Based upon these expressions you can draw a circuit diagram for the full subtractors. That's all. Thank you.